All right, each conditional statement below is true, so we want to write its converse. If the converse is also true, combine the statements into a biconditional. So number one, if a number is divisible by 2, then the number is even. So that's true, so let's write its converse. So if a number is even, right, so that's going to be our new hypothesis, then the number is divisible by 2. So let me write that. All right, so there it is. So I switched the hypothesis and conclusion. If a number is even, then it's divisible by 2. So is that true? Yeah, it is, right? So that's also true. So therefore, we can write the biconditional. So a number is even if and only if it is divisible by 2. All right, so there it is. And remember that biconditional is interchangeable, so we could also write a number is divisible by 2 if and only if it is even. All right, next statement. If two angles have the same measure, then the angles are congruent. So our initial hypothesis, two angles have the same measure. Original conclusion, the angles are congruent. So my converse is going to go the other way around. It's going to say if two angles are congruent, then they have the same angle measure. All right, so here it is. So is that true? If two angles are congruent, do they have the same angle measure? Yeah, they sure do. So since that's true, we can, we can write the biconditional statement. We can say two angles are congruent if and only if they have the same measure. Or two angles have the same measure if and only if they're congruent. All right, so there's our statement. All right, let's see the next one. So number 3, if x is greater than 5, then the absolute value of x is greater than 5, right? And that's true. You know, we already know that each conditional is true, but yeah, any number we could plug in for x that's greater than 5, like 6, 7, 8, etc., 9.7, and so forth, the absolute value will be greater of those numbers will be also greater than 5. So let's write the converse. So if the absolute value of x is greater than 5, then x is greater than 5. So this time I use the arrow notation. So is this always true? If the absolute value of x is greater than 5, then x is greater than 5. Well, I think we can find some counter examples, right? So I have situations where the absolute value of x is greater than 5 where x is actually not greater than 5, right? Like, for example, what if x is -6? If I plug in -6 here, the absolute value of -6 is +6, which is greater than 5. However, -6 is not greater than 5, right? -6 itself is not greater than 5. So that's a counterexample, so that proves this false. Therefore, we cannot make a biconditional statement out of this conditional. All right, so try 4 and 5 on your own. And remember, the idea is to first of all, write the converse, find the truth value of the converse, and if the converse and the original conditional are both true, then you can write a biconditional statement, or at least a valid biconditional statement.